G'day everyone, welcome to today's video. Today we're talking about the chain rule, which is a really powerful rule in calculus when we're trying to find derivatives. And when we use it is when we've got a function inside of a function, okay? So whenever you've got something, like you might have, e to the power cos x or something like that. Because e to the power x is a function, but you've got sort of this cos x inside of the e function. You've got a function inside of a function. That's when we need to apply the chain rule. And so effectively, what the chain rule says is that if you have this inside function n x, if you've got that inside function inside of another function m, then what we do is we firstly find the derivative of the outside function. You leave the inside function as it is. You don't do anything to it. You leave it as it is, and x stays the same. And then you multiply it by the derivative of nx. So you do that. And so that's what the chain rule says. You've got the inside function, you've got the outside function, you find the derivative of the outside function, you leave the inside function as it is, and then you multiply it by the derivative of the inside function. So that's how we write that in sort of Newton's way. How it's written in Leibniz notation is a little bit different, but it does the exact same thing. If you rewrite y equals f of u, so if you can rewrite, if you got y equals e to cos x, if you can rewrite it y as a function of u, you let u be equal to blah blah blah, and then you can find dy dx is equal to the derivative of y with respect to u multiplied by the derivative of u with respect to x. That all sounds like hoppy-coop. But when you see it as done as a problem, then it makes more sense. Okay, so let's just have a look at some examples that makes a lot more sense. So here we go. We've got a function inside of a function here. So you've got this function inside of this function. In other words, you've got that quadratic, and that's inside the function of something to the power of -5. So your inside function here is 3x squared plus 2x minus 9. Your outside function is something to the power of -5. You could call it x to the power of -5, okay? So that's what we've got. So I'm going to do this the slow way to start with, and I'll just sort of show you while you're sort of getting used to it, okay? So if I say let u be equal to the inside stuff, right? So if I let u be 3x squared plus 2x minus 9, so that's my derivative. Sorry, that's my derivative. That's my inside function. What that means that f of x is equal to u to the power -5. Okay, so u to the power -5. What I can sort of write is that's essentially that's y equals u to the -5. Okay, and what Leibniz notation says effectively is that dy dx, remember, just up above, is equal to dy, this is how you remember it, right? So dy dx like that, sort of write them diagonally, and then the u's sort of connect up, so it chains along that. Those u's are the sort of the connecting pieces in the chains, okay? And so what I need to do to find dy dx, therefore, dy dx is equal to, is dy du, so the derivative of this with respect to u. And so what is the derivative of u to the power -5? Well, the -5 comes down the front. Then you've got u, and then that -5 goes down by 1, so that goes down to -6. So that's the derivative, that's dy du. And then I need to times that by du dx. Okay, so just to be clear, I'll draw some things here. dy du, that is that. And now I need to do the du dx, and so I'll times that by du dx. So u, what did we say u was? U was 3x squared. Just highlight it here. That's our u there. So what's the derivative of that? So we just need to times by the derivative of that. The derivative of that is 6x plus 2. So I've got that. So there is my dy dx. So just to highlight what I've done, that du dx is that part there, and dy du is that part there. Just to finish it off, we can't leave it with a u in there, so we just plug that back in. So it's -5, and that u was 3x squared plus 2x minus 9 to the power -6, and then we multiply that by 6x plus 2. So that is the final derivative, okay? So there's the derivative of that function. So that I guess is the long way to go about using the chain rule. What the short way is effectively, I'll come across here. What color haven't I used? Green. I'll come over here and just show you. Effectively, you look back at this here and you think, well, all I do is I find the derivative of the outside function, you leave the inside function the same, and you times it by the derivative. So quite often when you get good at this, you'll be able to go straight to the derivative and you go, well, what's the derivative of the outside function? That's something to the power of -5. Something to the power of -5, the -5 comes down the front. The inside stays the same, so 3x squared plus 2x minus 9 stays the same. That -5 goes down to -6, and then we multiply it by the derivative of the inside, which is 6x plus 2. So you can just go straight to the end answer. As you can see, that's the same thing as that. That's all we've done is that. So the derivative of the outside is like, -5x to the power of -6. You can sort of see that x is like that inside function there. That's all that's happened there, and then you multiply it by the derivative. Hope that makes sense. Let's just do another one. I might do this one in the sort of slightly more faster way. Oh, no, I'll do it both ways just so that you can see what's going on. Okay, so I'm going to say let u be equal to the inside function, which is cos 2x. Okay, so u is the inside function, 2x. The outside function is e to the power of that. Okay, so that means that y is equal to 3e to the power u. Okay, 3e to the u. Therefore, and I'll just put a couple of things here. Now, therefore, dy dx is equal to dy dx. The connecting chain is du, is the thing that brings it all together. And so that's equal to, what's dy du? Well, that's the derivative of 3e to the power u, which is 3e to the power u. Nothing changes. So that's the derivative of y with respect to u. And then I need to times that by du dx. In other words, what's the derivative of this with respect to x? And so cos 2x becomes -2 sine 2x. Okay, so that cos goes to negative sign, and then that 2 comes down the front as that. And so that's it basically. And then I just need to put that u back in. U is cos 2x, so this is equal to 3e cos 2x multiplied by -2 sine 2x. We can probably just tidy up that 3 and that -2. So it'll be -6e to the cos 2x times sine 2x. So that's my final derivative there. Again, hopefully when you get better at these, you'll be able to see the shortcut. You can just see dy dx. You've got your outside function, you've got your inside function. I'm going to find the derivative of the outside function. The outside function, the derivative of e to the power of anything is just e to the power of that thing, so it doesn't change. The inside function, cos 2x, you just leave it. You write it exactly as it is, but then you need to multiply by the derivative of cos 2x, which is -2 sine 2x. And again, you can just tidy that up like we just did down there. So that's the chain rule. Let's just do one more. We've got an inside function, which is log e2x, and we've got an outside function, which is to the power of something to the power of a half. Okay, exactly the same thing. I'm just going to do this I'll do it both the slow way and the fast way. I keep saying I'm going to do it the fast way, but I'll just pause on that. And so I'm going to say let u be equal to the inside, log e2x. So that's my inside function. And so therefore dy dx is equal to dy dx, and du connects. And so dy du. And so I didn't write down what my y was equal to. So u is equal to log 2x, so y is equal to u to the power half. Dy du is half u to the negative half. Just have to write it in that y. Hopefully I can read that again when I get back to that. Half u to the negative half. and then we need to multiply that by du dx. What's the derivative of log e2x? That'll be 1 over x, if you remember. If you remember, you might be saying, well, isn't it 1 over 2x times by 2? Yes, it is, but that simplifies to just 1 over x. So that's all we have there. And I'm just going to put the u back in. So it's half. U was, what was u? Log e to the 2x to the power negative half times 1 over x. Again, I probably should just tidy that up a wee bit. So let's go, well, everything's on the bottom line, isn't it? So it's going to be 1 over 2x root, that's a root, just so you can see that, log e 2x. Did I get that right? Negative half, root half, so it's root log e 2x, 2x. Yep. So that's the derivative of that particular function there. Hopefully that makes sense. I'll see you all in the next video.